Hey there, thanks for clicking on this video. Uh, Here we have Rob and Kayla's Formal Lab 3. Um, for this lab, we have chosen to try and build a wireless light bulb using Nikola Tesla's mini Tesla coil to power this, which is a product that results in high voltage uh, energy that can jump from our Tesla coil to another object, in this case a wireless light bulb. Um, so yeah, I hope you enjoy. I hope you learn.
The diagram on the left is our first device that we are going to build. It uses a filament light bulb and a thick circled magnet cut in half. The light bulb's holder connection is wrapped in copper wire and then hot glued in between the two half-circled magnets. In theory, it's supposed to make the light bulb light. And then on the right is our second diagram. It uses a halogen light bulb this time. And on the sides of the light bulb are two thick magnets hot glued to each other. And on the bottom, there's a nail wrapped with copper wire, which is supposed to make the halogen light bulb light without wires attached to it. This is our third option in which we tried to build. It starts with a 9-volt battery connected to a transistor, which is then connected to a thick 1mm wire wrapped around the base of the mini Tesla coil. The Tesla coil itself is wrapped around tightly with copper wire, which was 27 gauge. And then the end of the connection of the copper wire was attached to a 22K resistor. And then looping back around, the resistor was connected to a switch and then the battery. So step one is to gather all the supplies. We bought a LED light bulb. We also bought a halogen light bulb. Next to that is a bundle of wires. We bought 40 feet of 27 gauge copper wire. Below that is the switch. We bought a 9-volt battery connection, the 9-volt battery, a 3/4 inch PVC pipe, electrical tape, and two different resistors. Next to that was the transmitter. So for step two, we are going to wrap the 27 gauge copper wire around the PVC pipe, making sure that there's no overlap on the wire or any bumps. We put a bead of hot glue around the bottom of the PVC pipe to help secure the wire from slipping off the end. For step three, we used hot glue to glue the 9-volt battery to the base. We also hot glued the two connecting wires coming out of the battery to the base so they would not move around during the building phase. In step 4, we connected the red wire coming off of the battery to the black wire on the switch. For step 5, we connected the black wire coming off the battery to the first connection on the transistor. For step 6, we connected the resistor to the middle connection on the transistor. In step 7, we connected the wire coming off the Tesla coil to the middle connection on the transistor, and we also connected the resistor to that middle section too. So since our mini Tesla coil did not work, we know that there were some issues. We think that since the diagram called for a 22K ohm resistor, but we only could find a 35K ohm resistor, so we think that affected it. Also, we could not afford more copper wire. It was very expensive, and what we had only wrapped around the PVC pipe 190 times when the diagram called for 256 times. Also, the wire coming off of the black switch was really thick compared to the other wires in the system. We think that this also messed with our resistance, and we didn't have enough voltage in our system to get the Tesla coil to work.
So, what's the purpose of a wireless light bulb nowadays? Well, first and foremost, this design offers great convenience. For instance, in the same way that Bluetooth technology and wireless charging have become the forefront of today's technology, our wireless bulb offers the same design and a way to strive in the market today in a wireless setup. Additionally, our bulb is powered by a portably sized station so you can move it around, and in an environment where a wired apparatus might not work and you can't have a direct connection to a power outlet, our bulb would offer a great convenience. Let's say if you're hiking but you don't want only to use a flashlight and you need a light bulb for something. And then on top of that, this light source doesn't require an outlet, so you can use a battery and it doesn't affect your energy bill or anything like that. And additionally, there's other power sources that could be played around with. One example is a magnet powered build in which you wouldn't have to pay for new batteries every once in a while, and you don't have to pay for an electric bill. So you might be saying, well, that sounds great and all, but well, how did you actually do this? And to answer that, we took an old design by Nikola Tesla, named the Tesla coil after him, and we used a miniaturized version of this. And the Tesla coil is basically a device that produces a high voltage, low current, and high frequency electricity, and it produces this into a space. And if you add an object like a light bulb into a close vicinity, well, the light bulb will light up as the energy transforms into it. And so to like start this off, we have our basic principle and our idea of voltage. It's the electromotive force, but we refer to it as energy per unit of charge. That's just a simpler way of thinking of this. And so we start out with this voltage, and the way the Tesla coil will work is it's going to flow into our transistor, um, and it's actually going to be boosted. It's going to be increased within the transistor. And then from there, as we have a higher voltage now, it will flow to a coil or our capacitor. Um, and the way this is going to kind of work, it's kind of like it's a sponge in water principle. So the energy will flow in and it's just going to get soaked up. It's going to get absorbed by this first coil. But as that fills and the energy builds to a top point, it's going to overflow. And we're going to have our second coil attached right next to this, which will receive the overflow and it's going to repeat the whole process again. But as that second coil overflows, it's going to overflow into this space that I referred to earlier, where we can, put a light bulb and you'll see it light up. There's also other demonstrations where someone may put their finger right next to this and you can just see a little bolt of energy traveling between them. And that's just a visual representation of what's going on here. Um, so that's basically how it works. That's how our light bulb will illuminate. But there's two other important parts to this. We have a resistor built into ours. This helps to filter and reduce any unwanted interactions from excess energy that may flow into our transistor and damage it, which would result in a damaged Tesla coil, which wouldn't be useful for us. So that's why we have that in there. And then additionally, we have a switch, just a typical on-off switch that we see all the time. And this allows us to turn the electricity on or off and inhibit that flow. So. Now, earlier I mentioned that the Tesla coil is actually older technology. It's not recent. Um, and that is true, but that doesn't mean it's not used to this day. Obviously, we use direct current all the time. It's a very simple and it's convenient um, technology. However, sometimes specialization is what's needed. It's useful and it's best for the job. And so here are a few ways that we use the Tesla coil to this day. Some materials, for instance, like aluminum, don't interact well with direct current. So if a welder is trying to weld and he's trying to use a direct current on aluminum, it actually won't interact in the way that they want. So many welding machines to this day use Tesla coil technology instead to weld this aluminum. And it's not the exact same technology, but it's built off the whole principle and uses the same core concepts in order to produce that electricity to complete the task. And then obviously a Tesla coil looks really cool. You can visually see this energy jumping across or illuminating a sphere, which is, it's very cool. It's like lightning in a bottle. And so many teachers and physics professors will use this as a way to show electricity to their students and educate them. But they're not the only people that take advantage of how this looks. In fact, Hollywood uses it all the time. Um, it's used in movies and special effects, but additionally, it's used in music videos, which I think is really cool. Or stage performances and those type of things where they sync the electricity from the coil to the music and they use it in the display, which is pretty awesome. And then additionally, I thought this was kind of cool, is we use this Tesla coil concept and the arc of electricity as the electricity goes from the coil to this other object in lighters nowadays. Um, it's called an arc lighter, and it has a light stream that bends in the form of an arc from one end of a lighter tip to the other. And this is a really cool invention. It looks really cool. It's kind of fun. It could be used as a party trick. You know, you want to stand out. But additionally, since it's not just an open flame, it doesn't have to, or it doesn't interact the same way that a flame would. So if you're outdoors and it's windy and maybe it's a little rainy, that flame from like a regular lighter or a Zippo or something is probably going to be blowing out, or it's going to be blowing sideways. I think we've all seen this effect. However, with the arc lighter, it's not going to do that because it's using this current arc technology, which is really cool. And you also don't have to worry about always having lighter fluid since it doesn't use that and it recharges quickly. So the beginning of the slide, you may have seen the picture of the man in black and white and gone, "Oh, I wonder who that is." And I'm hoping that, you know, through the name dropping of this video so far and the picture in the top right of an unnamed car that many people know, you guys can guess who we're talking about. That man is Nikola Tesla. He's pictured in the bottom of right of this slide too. And he was an electrical engineer. He was far beyond his time, just an outstanding creator. Um, you know, rivaled Thomas Edison, and they competed for electricity and creations of their time period. You know, he's really the father of AC or alternating current that we talk about today, but that's not the limitation of his great inventions. He's behind, you know, or his concepts are behind radio. He built the hydroelectric powerhouse at Niagara Falls, which, you know, powered New York and Buffalo. And yeah, he's behind, you know, the first electric car, which is pretty amazing. He was never satisfied with his work. He always pushed for more and more and more. And, you know, we're very lucky today that that was the case because he is behind so many of these great inventions and our understanding we know now. You know, he pushed himself to bankruptcy, actually, you know, mortgaging all of his stuff, trying to keep his inventions alive. And unfortunately, after he passed away, you know, his legend was kind of not forgotten by everyone, but he wasn't a household name like Thomas Edison is. Um, but fortunately, in 2003, a little fun fact, Elon Musk started the company, which is now known as Tesla, and he named the company after Nikola Tesla as kind of a tip of the hat to him and all of his great inventions. And it's very fitting since Tesla invented this first electric car. And now, you know, Tesla, the car company, is the leading engineering company for motorized or electrically powered vehicles to this day, which is it's very fitting. Hey, congrats! You've made it to the end of our video. I hope this was interesting. I hope you learned something. Um, Obviously, unfortunately, our build didn't go as we planned it. We ran into some issues with our materials. We're getting some limitations there, which hindered our bulb from getting the energy to light. But unfortunately, you know, sometimes that's just how our designs and building goes. I think Nikola Tesla could agree. Um, you know, that's not always a perfect process, but I hope through our blueprints and you know our background information that you were able to see and maybe learn or understand something from this project and that you enjoyed it. Below on this slide we have our APA style citations from videos that gave us inspiration and design ideas. So yeah, thank you for watching and we hope you enjoyed it.